Hello, this is Dr. Strickland. In this video, we're going to finish our investigation of chemical evidence by talking about limiting reactants and theoretical yields. Now, this is going to build on everything that we've been doing in the last couple of sessions. You can see we're going to balance the equation, draw a roadmap to plan the work. Okay, so we haven't drawn a roadmap yet, but we will in this one. Then we're going to work the plan. It will involve calculating some molar masses, and then we'll use some molar ratios, and then molar masses will come back again when we're calculating theoretical yields. And so we'll talk about that as we go. So in a chemical reaction, there may be one reactant that runs out first. Sometimes the reaction's planned so that there's exactly the right amount of two or more reactants. But generally speaking, one of those reactants is going to run out first. And the one that runs out first is called the limiting reactant, because when it runs out first, it limits the maximum amount of product that can be formed. And that maximum amount of product is called the theoretical yield. There's more than one way to determine a limiting reactant. So I'm going to show you the way that I like the best. If you know another way from an earlier chemistry class and you can show me how it works, that's fine with me. But we're going to work in the context of this practice problem. All right, post-mortem analysis of bodily fluids can provide investigative leads. For example, low levels of chloride ions in the blood serum may indicate that the victim was dehydrated or possibly suffered from congestive heart failure. The presence of chloride ions can be determined by the formation of silver chloride in the following precipitation reaction. Okay, and that's this one down here. Silver nitrate plus sodium chloride would give you the precipitate, sodium chloride, and sodium nitrate would be the other product, because remember, in a precipitation reaction, that's one of these double replacement or metathesis reactions where the cations change places. All right, so the thing we ultimately want to do is to determine the theoretical yield of silver chloride and the limiting reactant. So which one of these reactants is the limiting reactant? If at the start we had 30 grams of sodium chloride mixed with 30 grams of silver nitrate. All right, so the first thing you would do in the strategy that I've laid out for you here is look and, first of all, see if it's already balanced. And then if it's not, do whatever you need to do to balance it. I would never assume that it's balanced, because if it's unbalanced and you do all your math, it's wrong, because you don't have the correct molar relationships. All right, but in this case, one silver on both sides, one nitrogen, 3 oxygens, 1 sodium, 1 chlorine. So it's already balanced. All right, so we can check that out. Now we're going to draw the roadmap to plan the work. All right, so I'm not going to use the physical state symbols, just to make things a little simpler, because we really don't need them right now. And we've got them right there if we need them. All right, so in order to find out whether 30 grams of sodium chloride is going to run out first or 30 grams of silver nitrate is going to run out first, we're going to calculate the amount of this product of interest, silver chloride, that would be made by this one and then by that one. So if I wanted to know about it from silver nitrate, I would draw a roadmap that looked like this. So I would put 2 boxes under the 2 substances that I'm interested in, connected by a line. And the top one represents mass, and the bottom one represents moles. And you can get between mass and moles if you know the molar mass of either compound. So you can do that for silver nitrate. You can do that if you needed to for silver chloride. Now, the connection in any chemical reaction is between the number of moles, which is revealed by the coefficients in the balanced equation. So the molar ratio, that is, how many moles of one thing does it take to make, say, the product, like in this case, the molar ratio is it takes 1 mole of silver nitrate to make 1 mole of silver chloride. Okay, so we're going to start with 30 grams of silver nitrate. So we're going to start here. And where I want to stop is with the mass of silver chloride that would be made. So I'm going to draw some arrows. I'm going to go from here to here, and that will be one calculation. And then here to here, and that's a calculation. And here to here, and that's the last calculation. But all the thinking part is over at this point. So I'm going, we would need to calculate the molar masses of these two things. And for purposes of what we're doing right now, I'm just going to tell you what they are. So for silver nitrate, the molar mass is 169.872 grams per mole. And for silver chloride, the molar mass is 143.321 grams per mole. And you can see that the molar ratio between these two is 1 mole of silver nitrate makes 1 mole of silver chloride. Let's put this under there and give us a little more room. Okay, now we've got all the pieces. Now you can do this as 3 separate calculations. I'm going to show you how to set it up as one. But if you want to do it as 3 separate calculations, that is absolutely fine. So you can say, 30 grams of this first reactant and set it up to calculate the number of moles of silver nitrate using the molar mass as a conversion factor. So 1 mole silver nitrate, and that is equal to 169.872 grams of silver nitrate. Okay, so you can get an intermediate answer here, and then take that on to calculate the number of moles of silver chloride, and get that answer and take it on to calculate the number of grams of silver chloride. If you want to do it as one long calculation instead, then each one of these arrows represents a conversion factor. So you'll start with the measurement, and then you can do the 3 different conversion factors. And either way is fine. If you can get to the point where you can do it this way, it will save you some time, but you do not have to. Okay. So this is the molar mass of silver nitrate. We've gone from grams to moles of silver nitrate. Now I need to go from moles of silver nitrate to moles of silver chloride. There's 1 mole of silver chloride formed for every 1 mole of silver nitrate used up. Okay, so moles of silver nitrate cancel. And then to get to the grams of silver chloride, 1 mole of silver chloride has 143.321 grams of silver chloride in it. Okay. And then you multiply everything in the numerators, divide by everything in the denominators. And if you want to have everything have a numerator and a denominator, just put a 1 under your measurement. Okay. So the units are correct. So I want you to run this calculation and come on back. All right, welcome back. So when I considered that I can only keep 3 significant figures, I got 2.52 grams of silver chloride. Okay. Now you can set up another roadmap for sodium chloride if you wish. And so then the 2 substances would be this and that. And you'd do 2 boxes under here, 2 boxes under there. Similar roadmap to what we did here. Or you can just do the parallel calculation. And you do have to have the molar mass of sodium chloride. So we're going to consider the second reactant. You can put a 1 under it if you want. we're going to have the molar mass of sodium chloride, the molar ratio between sodium chloride and silver chloride, and then the molar mass of silver chloride is the same. Okay, so just a minute, I'm going to ask you to calculate the molar mass of sodium chloride. You can see from the balanced equation that you form 1 mole of silver chloride for every 1 mole of sodium chloride. Okay, so first thing to do is that, and then that, and then we'll take a look at our results and see what it all means. I'm sorry, I'm talking to myself. Okay, so I've set up the parallel calculation for sodium chloride. It involves the molar mass of that reactant, the molar ratio between that reactant and the product, and then the molar mass of that product. So first thing I want you to do is find the molar mass of sodium chloride. So pause the video and do that, and then come on back. All right, welcome back. So 58.443. All right, so grams of sodium chloride cancels, moles of sodium chloride cancel, moles of silver chloride cancel. That leaves me with grams of silver chloride. Now I want you to run the calculation for this relationship between the mass of sodium chloride at the beginning and the mass of product that would be made. I said, pause the video and do that and come on back. All right, welcome back. So if you run this calculation, you get 7.50 grams of silver chloride. And the question is, okay, so which one of these is the mass of silver chloride that could be formed, the maximum amount? Well, you can see that silver nitrate is going to run out when this much silver chloride has been made. So that means that this has to be the theoretical yield. And this reactant has to be the limiting reactant because it will run out first. So the smaller of these two values is the theoretical yield. So if we come on down here, the theoretical yield is 2.52 grams. I'm sorry, I put it in the wrong place. Well, that's not happy. Theoretical yield of silver chloride precipitate is 2.52 grams. And the reactant that made that happen, you got to choose this or that, right? So the reactant that produced that much silver chloride is the limiting reactant because it will run out first. Okay. All right. So please answer the question at the end of this video, and I will see you in class.